So section 5.2, I was just looking at this one, and we're going to kind of go a little bit all over the place in the middle because we're not doing the graphing part today. We're only doing certain things. So we're going to do the things like that are going to be in your assignment. So that's why it's going to look like we're skipping stuff, but we'll go back and kind of fill in the rest of it tomorrow. So we are going to analyze the factored form of a polynomial. We're going to do a few things there. And we're going to write a polynomial functions from its zeros. So we're going to do both of those things today. When you find the zeros of a polynomial function, it helps you graph it, and it also helps you do related polynomial equation things. So first part of this is going to be super easy. We'll kind of whiz right through this. What is the factored form of x cubed minus 2x squared minus 15x? So this is really what we were doing in the last few weeks, except it has cubed in it instead of squared. So we cannot put 1 for A, negative 2 for B, negative 15 for C in the quadratic because there's a 3 in there. So we need to make this simpler to see if we can factor it. So is there anything we can take out? We can take an x out. And always take out as much as you possibly can. Okay, so I'm going to take an x out, which leaves me x squared minus 2x minus 15. Many of these, when they say, give me the factored form, they're going to be things that are easily factored. You're probably not going to have to go to the quadratic, although you could if you wanted to. So now we look at the stuff that's left in parentheses. I'm going to leave my x out there. Even if there's a number out there, just leave it. What are factors of negative 15 that add up to negative 2? And which one's negative? Okay, so x minus 5, x plus 3. You can always do that little table on the side where you have factors of negative 15 that add up to negative 2. In this case, one has to be positive, one has to be negative. The biggest one is negative because the middle sign is negative. So whatever the one in the middle is kind of dictates which one gets the negative. And do we have it factored? We do. We are done. Yep. At the beginning, there won't be if you can take something out. So it'll always work that it either is like it should be at the beginning, or when you take something out, it'll work. Okay, so she said, what if there was something like a minus 2 at the end of this one? You guys don't know how to do that yet. Okay, eventually we'll know, but not today. So it should work out good. So we are done with this one. Now, is that one of the easier problems you've done this year? Good, and I think you'll find that this day is a lot easier than it was yesterday. Okay, let's look at, this looks a lot more complicated than it is, and I think I might go over this part tomorrow. Okay, I think it's more useful in tomorrow's section. And we are going to do part of this one. All we're going to do is finding the zeros on this question. Okay. They didn't do super amounts of problems in this one, so I'm just kind of skipping around to the ones that I want to look at. So once we have it factored, we want to know what the zeros are, and all you really have to do is change the y equals to a 0 equals. And then set each part equal to 0. So x plus 2 equals 0. That would give you x equals negative 2. X minus 1 equals 0 gives you x equals 1. X minus 3 equals 0. X equals 3. Okay, and we've actually already done that part as well. So that part should not look new either. Now, if we had to graph this, which we're not going to do today, what we would do is we would take our graph paper and we would put a dot on the x value negative 2. We put a dot on the x value 1. We put a dot at the x value 3. And then tomorrow what we're going to do is we're going to put the end behavior and then how we do the middle kind of all in there. And it's not going to be a super exact thing tomorrow. It's just going to be kind of an estimate or, you know, what might this graph look like. It's not going to be super exact. So they're not as hard as what they might sound now. So that's all we're doing. So we've already factored. We've already found the zeros. That's 2 parts in the assignment that you guys have for tomorrow. Let's go here. The factor theorem. The expression x minus a is a factor of a polynomial if and only if the value a is a zero of the related polynomial function. What that means is this. If you have the answers, the zeros to these, we can actually go backwards to get the polynomial function instead. So instead of taking the polynomial function and factoring to get the zeros, we're going to take that and go backwards. It's basically all about multiplying. If you can multiply things in parentheses, you're going to be good to go here too. So our question is, what is a cubic polynomial? So what's cubic? What exponent would that be? So in the end, you should come up with something to the third power because it's telling us we want a cubic function in standard form, which means they have to be in descending order at the end, with zeros, -2, 2, and 3. So I'm going to start out like this. X equals -2 because that's what the zeros kind of look like. What we're going to do is we're going to make them into factors. How we do that is we bring everything to the left. So on this one, if I add 2 to both sides, it would make it x plus 2. What would the next one be? Plus 2 or minus 2? Minus, because when you subtract 2 from both sides, you get x minus 2. And the last one, is it x plus 3 or x minus 3? Minus 3. And that's going to equal 0. I'm going to put in what I'm doing here. Okay. Now it's all about multiplying. Can you multiply 3 things at a time? No. So we're going to take any 2 that we want, and we're going to multiply them, and then we're going to take that answer times the last one, okay? So it's kind of seems like it's a long procedure, but be selective in what you want to multiply first. So when I look, I see an x plus 2 and an x minus 2. That is the easiest possible thing I can do first because I already know what it looks like. Okay, so I'm going to take these 2 first. Just because I take these 2 doesn't mean you can't take the other 2. It doesn't matter as long as you're multiplying everything times everything. Could be a long day. Kind of takes us back to last year, doesn't it? When the board shut off like every 35 seconds. Okay, so when you have a plus and a minus, do you have any middle terms at all when you multiply? No, you can write them all out if you want to. You can go x times x is x squared. -2 times x is -2x. 2 times x is 2x. You can write them all in there if you want to, but I already know that the middle terms are going to cancel. So you can, I'm going to write them in this time, but I wouldn't if I was doing this one. So I'm going to go outside terms, -2x. Inside terms, positive 2x. Last terms, -4. Okay? Those cancel every single time. Foil. That's all we're doing is foil. And it doesn't matter if you do them in the wrong order because you still have all 4 terms. Okay? Now, that gives us x squared minus 4 times x minus 3. Now we have to FOIL that out. So it's like you're taking 2 at a time and you're taking the answer of this one times that last one. I'm going to try to squeeze this one in at the end. So x squared times x would be x to the third. X squared times -3 would be -3x squared. -4, these are the insides. -4 times x would be -4x. And -4 times -3 would be positive 12. Now, do we have a cubic polynomial in descending order? We are done. Okay, so the only thing I'm going to do is instead of putting a 0 there, I'm going to write it with a f of x since they're asking for a function. So x to the 3 minus 3x squared minus 4x plus 12. And I'm just going to write FOIL here. So if you are doing, sometimes you have to do 4 of these, okay? Like the next one is asking for a quartic, that's 4. I'm going to show you kind of how to be selective about which ones you multiply first. So we'll do one that's a little bit more complicated than this one, but they probably wouldn't make you do more than 4, okay? Because that just takes a long time. Okay, did everybody have this one? Here's a quartic, which means the highest exponent is going to be a 4. So things that we've learned, keep those in mind. So this one, I'm going to need some space, so I'm going to start way over here. My zeros are -2, 2, and 3. So I have x equals -2, x equals -2, x equals 2, and x equals 3. Now, when I do these, I know I'm putting them in factor form right away, so I just go right into that. If you don't want to do this step, that would be fine. I go right into x plus 2. What would the next one be? X plus 2. What's the next one? X minus 2. X minus 3. If you can go right into that, go for it. It's the same thing. We're just doing one little step ahead of it. And remember, we're just bringing everything to the left so it looks like a bunch of factors. Now, when you do 4 things, you want to be a little bit more selective about what you multiply. Now, didn't we just do one where the middle terms cancel? That's the ones that I go for first. So what I see when I look at this one is these. Because I know that we just did that one and the middle terms cancel out. So I'm going to do those 2 first, but I can't forget that I still have the x plus 2 and the x minus 3 after that. Okay, so I'm going to multiply just those. I'm leaving everything else where it is. So x plus 2 we haven't done anything with. This one is going to be x squared minus 4. Because the middle terms cancel, you get a minus 2x and a plus 2x. And then we have an x minus 3. Now, from here, it's really whatever you want to do. If you want to do the x plus 2 and the x minus 3 first, and then multiply it by x squared minus 4, that's probably what I would do. So I'm doing these 2. You can just take them 2 at a time and do them that way as well. So I'm doing these 2 this time. Okay, so I get x squared minus 3x plus 2x. If you can do that all at the same time, do it. If you can't, put them in here. So I did the outers and the inners, and now I need a minus 6 for the last. And then I'm going to simplify it. Yep.
Why do we simplify, or I mean FOIL on that one, but not on x plus 2 and x minus 3?
Because we just did that one and we did FOIL them, and we found out that the middle terms cancel.
But you still get x squared minus 4?
You still get x squared minus 4. Because you get x squared minus 2x plus 2x, and those cancel. So I just saved myself. You can always write them in if you want to. Okay? So we get equals 0. And now we have to multiply one more time. This is the one that gets a little tricky, and I always kind of do this. And this is kind of like an extended FOIL, but I don't keep track of the letters. What I do is I take x squared times each one of these, and then I take -4 times each one of those. Okay, so, or you can do this one times this one times this one. Then you can go to the next one. Okay, so as long as you get 6 terms at the end, you're good. Okay, I'm going to do x squared times each one, -4 times each one. Kind of like distributive property is what I'm looking at. Okay, so x squared times x squared, you're going to add the exponents and you get x to the 4. x squared times negative x would be negative x to the third. Again, add those exponents together. This has a 1. And then I get x squared times negative 6. So I've done 3 of them. I need to do 3 more. I'm going to do the negative 4 now. Negative 4 times x squared is negative 4x squared. Negative 4 times negative x would be positive 4x. And negative 4 times negative 6 is positive 24. There should be an equal 0 in there. Now we're going to simplify a little bit and we are done. X to the 4, and we know it's going to be a function, so I'm going to actually do it right now. So x to the 4. Are there any other x to the 3's? No. Are there any other x squareds? There's a couple of them, right? You're going to put those together. Negative 10, x to the 2. There's no other x's, and there's no other numbers. So, looks a lot longer than it really is. It's all about multiplying on this one. If you can get those factors going at the beginning and you can keep track of where you've multiplied, this one isn't extremely bad. Anybody have questions about what we did on anything there? Av?
I don't get how you got any of this stuff right. Like, how do you boil all of those?
I took x squared times each one of those. Those were like the first 3 things that I did.
You got your first, and then
Yep. And I'm not even keeping track of outer. I'm not doing FOIL on this one. I'm doing kind of like a distributive property. I took this one times this one times this one times that one. Kind of like I'm distributing just the x squared times these 3. Then I'm going to do the same thing with the negative 4. So I took negative 4 times this one, negative 4 times that one, negative 4 times that one, because FOIL only has 4 letters and we have more than that. So that's why I kind of just did distributive instead.
Okay.
I'm going to do this. I'm going to write it up here. I did x squared times this. And I did negative 4 times this. Does that help if you look back on it?
Yeah.
Okay. So that's this one and this one. Those are the 2 separate things that I got. Okay. So a lot of multiplying there. I need to look in my book for a second to see how much else we need to do. That might be it. Okay, we need to do one more thing. Okay, so tomorrow what we're building up to is once we get the factors, we can get the zeros, and we put them on the graph. Okay, so we're going to have sometimes 2 numbers, sometimes 3 numbers that we can put on the graph. We already know, excuse me, how to do the end behavior, because we can look at a polynomial function and we can go, is this one even and positive, or is it odd and negative? So what's the end behavior? So we're going to know, is it up on both sides? Is it down on one side, up on the other? How does that come into play? And then what we're going to do now is, how do you do between those dots that we put on the graph? And that's what we're going to learn right now. So we can do a quick sketch of what this thing looks like, even if we don't do an XY table, which takes a long time. Okay, so multiplicity. I'm going to go right to here. I'm going to try to make it easier to understand. Let's see, multiplicity. To find out what the multiplicity is, what you're going to do is you're going to look at the exponents of the factors. For instance, if you have something like this, and I'm just making this one up, it's not in the book. Let's say we factored something and we got this. How many x plus 2's do we have? 2. So what we're going to do is we're going to take it and we're going to go like this. Okay, and what that means is, 1, if you solve this thing right here, I'm going to change colors for a second. This one gives you x equals 1, right? This one. How many of those do we have? 1. So behind it, you're going to put mult 1. That means it has multiplicity 1. There's one factor of that. That's all it means. One factor of x minus 1. If you solve this one, what do you get? X plus 2 equals 0. X would be negative 2. So x equals negative 2 has how many factors? 2. So this one would be multiplicity 2. No, the sign of these don't matter. Nope. How many factors of x minus 3 do we have? 1. And what would the answer be if we actually solve this thing? You get x equals 3. X plus 2 equals 0. X would be negative 2. You have to actually solve it, like if you were solving an equation with this thing in it. Does that make sense? Like if you had these as factors and it would equal 0, and you'd actually have to find the numbers. This would be multiplicity 1. Now, you're thinking in the grand scheme of life, what does that even mean? When you look at the graph tomorrow when we're doing these, you're going to know, does it go through that point using multiplicity, or does it just touch it and go the other way? Okay, so if I draw a really crazy graph here, I'm going to tell you, and this one I'm just making up, and then I'll have to erase it, I guess. Yep.
Is there a reason that 3 is a multiplicity of 1?
Because the exponent right here is a 1. It's just not there.
It's not the exponent, it's not...
It's not the number, it's the exponent.
Oh, so like yesterday?
Yes.
Oh.
Yep. So the multiplicity is the exponent, or how many factors of it do you have is basically what it is. So on this one, with multiplicity, you can kind of decide what the graph looks like. So tomorrow we're going to say, you know, on this one was positive and even, so it goes up on both sides. You're going to have these numbers as zeros. Okay? And you put those on the graph. And if it is a factor of multiplicity 1, it goes through it. If it is a multiplicity 2, or if it's even, it touches it. So like this one would be a factor twice. These would only be factors once. And we'll go through all of it again, but that's what we're leading up to. We're only doing parts of it today. So the multiplicity tells you, does it go through the point or does it touch the point? That's what we're going to do tomorrow. Okay, so you don't have to know any graphing today. I was just kind of showing you what we were going to do tomorrow. Let's do one where we do the zeros and the multiplicity so you can kind of see it from the start. So on this one, we have x to the 4 minus 2x to the 3rd minus 8x squared. Can we take anything out? X squared this time. Remember to subtract the exponents. So x to the 4, we're taking out 2 of them. There would be 2 left. 4 minus 2 is 2. The number is still there. What's my exponent on this x? If I had 3 and I took 2 out, get 1. And then on the last one, I only have the number because I had x squared and I took them both out.
Can we put a 1 by the x? Or is that
Yep, absolutely. Put the 1 if you want. So we are dividing numbers and subtracting exponents when we're taking things out. So here we didn't take a number out, so we're taking x to the 4, x to the 2, we subtract those. X to the 3, x to the 2, we subtract them. x to the 2, x to the 2. We subtract those exponents. Now we factor the inside. I'm going to bring it over here. Factors of negative 8 that add up to negative 2. What are those? What? Negative 4, positive 2. Yep. We subtracted the exponents because we took x squared out. So what you do is you take 3, subtract 2, and you get 1. 2, subtract 2, and you get 0.
So you'll subtract it to the outside.
Yes. Whatever number's on the outside, that's what you're subtracting from. Yep. Now we have to solve each part. So I set each one of these equal to 0. X squared equals 0. X minus 4 equals 0. X plus 2 equals 0. And then we solve each one. When I get x squared equals 0, don't I just get x equals 0? Because the square root of 0 is 0. What if I had x squared equals 4? Which you're not going to have. You'd have 2 answers, right? So it's kind of like what we're doing there is square rooting both sides. Then the next one gives me x equals 4. And the last one gives me x equals negative 2. So all we're doing is solving for x. What? Yes. Now we're going to take those answers and put multiplicity behind it. So all we need to add is this. So what you're going to do is you're going to go back to the factored form, this one, and check it out to see what it is. So here was my x equals 0. Here's my x equals 4. Here's my x equals negative 2. How many x equals 0s did we have? How many of that factor is there? 2. So it's multiplicity 2. So this exponent is the multiplicity. So whatever the exponents on these factors are, that's what it is. So what is the exponent on x minus 4? 1. So I'm going to say multiplicity 1 there. What is the exponent on x plus 2? 1. So it's multiplicity 1. How many of them do you see? 2 of them. I could write this as x and x, right? But I don't want to. How many of those do you have? 1. How many of those do you have? 1. So it's how many of each factor do you have? If you had something where you had x minus 2 and x minus 2, you would group them together first. But normally it kind of works out nicely when we're just doing the factoring like it is.
Why isn't it 1x squared? Why is it?
You can have 1x squared.
And you still get 0? Is it equals 0?
So the equals 0 part is only coming from here. I'm just copying these down. That's where those are coming from. So you're taking what your answers were and you're just adding the multiplicity behind it. So once you get the answers, go back to the factored form because the first answer is going to be from this one. Second answer is going to be from that one. Third answer is going to be from that one. And you're looking at the exponents only. Okay, now who doesn't get what I just did? There's lots of arrows now, but there wasn't before. Okay, so take your answers from factored form. That's what these are right here, if they erase. So I took those answers and I broke them down. So x equals 0, x equals 4, x equals negative 2. Those are right there. Then I look up and I went, x equals 0 came from this one, but I have 2 of them. It's multiplicity 2. Exponent is 2, multiplicity 2. Here, x equals 4, that's what it gives me, but how many do I have? 1, because the exponent there is 1. This exponent is also 1 because there's a 1 there whenever there's not a number. So you have multiplicity 2, multiplicity 1, multiplicity 1. And that's going to tell us how many times these are going to be on the graph tomorrow. Okay? Now, I see some going on. So we're going to do one more of these right here. But I'm going to have you guys try it first, and then we'll go over it. Okay? Let me see if I have one. If not, we can do something in the book. Yeah, let's do something in the book.